factoring. Today we're going to be factoring trinomials. And trinomials are expressions with three terms. And so if you look at this trinomial here, we have x squared plus bx plus c. That's got three terms in it, and we're going to factor it. And sometimes you'll see this written as ax squared plus bx plus c. And that's the same form. Here, what we're going to be dealing with today is that we're only dealing with ones that have a as 1. And so you'll see this terms down here. We have an 1x squared plus 4x plus 3. And that's what we're going to be factoring. Now let's talk a bit about factors, because when we have factors like x plus 4 and x plus 3, we know how to use the distributive property, or FOIL, first outside, inside, last, if you recall. We know how to use FOIL to turn that into something that looks like the trinomial that we're looking at right now. We multiply x times x, that's x squared, and then x times 3, that's plus 3x, and then x times 4, or 4 times x, and that's 4x, and then 4 times 3, which is 12. And so we get x squared plus 7x plus 12. And so if you look at that, what we're going to do today is we're going to take this x squared plus 7x plus 12, and we're going to turn it back into an x plus 4 times an x plus 3. So we can find its factors. Okay, so that's what factoring is. So we're going to look at this using the FOIL method and the box method so that you can see both ways. So every one of these is going to turn into two binomials. And those two binomials have to have their first terms multiplied together, because remember we did first here, to get this first term. So the first terms multiplied together have to be x and x, because the only way to get x squared is x times x. Then we look at the last term. So we're going to do the first and then the last. And the last term we get over here by multiplying 4 times 3, that's 12. Well, what things multiply together to give us 3? Well, just 3 and 1. And so we're looking at the factors of 3 that we can put in here that we can then add together, because what do we do with those middle two terms? Here we add them together. So we're adding those middle two terms together to get the x term in the middle. And so let's just check this out. If we have x times x, that's x squared. And if we have x times 3, that's going to be 3x. And if we have x times 1, that's going to be 1x. And if we have 1 times 3, that's going to be 3. And does that give us x squared plus 4x plus 3? Yes, it does. And so these both have to be positive in here, because that's the only way we would get pluses in between all of these. And because really this is a positive 3 and positive 1 here multiplied together to give us a positive 3. Now, could we have negative 3 times negative 1? What would that give us? Well, negative 3 times negative 1, if we put negatives in here instead, that would actually give us a negative 3 down here and a negative 1, which would give us a negative 4x as the middle term. So we know that it can't be the negatives here. It has to be positive. Negative times negative is positive, but since this one in the middle is positive, then both of these terms have to be positive. And that's really what we're most concerned about here, is what sign it is that's going to end up in the terms. So what are the factors of x squared plus 4x plus 3? They are x plus 1 and x plus 3. Those are the two factors. Now, binomials can be multiplied by using the FOIL method. In each case, the product is a trinomial. And so that's what we just discussed. We're going to get this trinomial every time we multiply two binomials. Or if we take the factor of a trinomial, we're going to get two binomials. So And the coefficients of the middle term is the sum of the last terms of the binomial. So we're looking at these. So here's another one, x squared plus 9x plus 18. We have, we're going to turn this into two binomials. And our x squared term has to give us x times x, because x times x is x squared. And then we have to figure out factors of 18 that will give us 9 when we add them. And when we add them, they're going to be positive, so we know they have to be both positive. So both of these signs are going to be positive. Now we have to figure out the factors of 18. Well, 18 is 1 and 18, 2 and 9, 3 and 6. Which of these factors, when you add them, gives you 9? Well, that gives you 19. When you add these, that gives you 11. When you add these, that gives you 9. So it can only be the factors 3 and 6. So 6 times 3 is 18, and 6x plus 3x is 9x. And again, you want to always check these when you're done to make sure that that's correct. So let's do it. X plus 3 times x plus 6. X times x is x squared. X times 6 is 6x. 3 times x is 3x. And 3 times 6 is 18. And does that give us x squared plus 9x plus 18? Yes, it does. So check these when you're done and make sure that they gave you the right terms there. And again, remember, these are always multiplied together to get the last terms, the last term here of 18. And they're added together to get that middle term that we're looking for, the 9x. So that's why it has to be 3 and 6. And so I wrote this out, how they have it written in the book, so that you could see each step, how they did it. So again, they had the products, and then they had the sums, and which one of those sums fit our product and sum. So this is the product, that's a multiplication, here's the addition, the 9, and so we get x plus 3 and x plus 6. So here's another one. Again, this is going to factor into two binomials. And they both have to be positive or they both have to be negative. So what are the factors of 4? Well, 4 and 1 and 2 and 2. And when you add those factors together, which one of those gives you 5? So let's add them together. This one gives you 5. That one gives you 4. So we know it's going to have to be the top one, but how in the world are you going to get negative 5 out of that? Well, if you remember, the factors can be 4 and 1, or they can be negative 4 and negative 1. Because when you multiply 4 times 1, you get 4. And when you multiply negative 4 times negative 1, you also get 4. So here, our first term, x times x is x squared. Factors of 4 that we're going to use are 4 and 1, and they have to both be negative. Check it. X times x is x squared. X times negative 1, negative 1x. Negative 4 times x, negative 4x. And negative 4 times negative 1. Does that give us x squared minus 5x plus 4? Yes, it does. So our factors are x minus 4 and x minus 1. Now, let's look at the box method, because if some of you are having trouble with this method, the box method might make more sense. So in the box method, remember we put those binomials out here, but we don't have those binomials. That's what we're trying to find. So we're going to put the stuff we have in the box. So we know this is going to be the x squared here, and we know that this is going to be the 4 here. Those are the first and last terms. And we know that the middle terms have to add up in this box. So we know that this is going to be x and x. And we have choices again of 4 and 1 or 2 and 2. And so we're going to put those in and try them. So if we put a 4 in here and a 1 in here, that would be a 4x and a 1x. And that's correct because that would give us 5x. And then we know that these have to be both negative because we want a positive 4 here, but we want these to be negative because we want that middle term to be negative. So then we know then that this is x minus 1 and x minus 4. All right. So factoring when c is negative. So you notice in those first ones we had a positive term here. Now we have a negative term. And so we're still going to factor it the same way we factored it. But this time, one of them has to be positive and one of them has to be negative. Because in order to get a factor of 10, negative 10, we have to have negative 2 times 5. Or we have to have 2 times negative 5. Or we have to have 1 times negative 10. Or we have to have negative 1 times 10. So those are all the factors of negative 10. It could be 2 and 5, but it might be 2 and negative 5, or negative 2 and 5. So again, let's start out with our x's. X times x is x squared. We know we're going to have the factors of 10 here, but they're going to subtract. So when this is negative, you're going to subtract. And when it's positive, you're going to add. So we're going to subtract those two numbers that are factors and get 3. So here, 5 and 2, if you subtracted them, you would get 3. So we know it can't be the 10 and 1. 10 minus 1 is 9. So we know that it can't be that. So we have to use the 2 and the 5. Now we have to decide, if we subtract them, how will we get a positive 3? Well, if you take negative 2 and positive 5, that gives you positive 3. If we took the second set and did 2 plus a negative 5, that would have given us a negative 3. So we know this has to be negative 2 and positive 5. Now, it doesn't matter which order. We could also write this as x plus 5 and x minus 2. It doesn't matter which order they're in, as long as the 5 is positive and the 2 is negative there. And so factored, this one is x minus 2 and x plus 5. So try the next one. Again, always factoring into two binomials. We know we have x and x. And then we know we have the factors of 8. And one of those is going to be negative and the other is going to be positive. And so we have to decide which is which, because we're going to subtract them. And 8 minus 1 gives us 7, and 4 minus 2 gives us 2. So we know it has to be this one to give us the 7 in the middle. So then we have to decide. We know these are 8 and 1. And so we're going to have a negative in the middle, so which one has to be negative? Well, it has to be negative 8 plus 1, because 8 plus negative 1 would give us positive 7. This one gives us negative 7. So this has to be a positive 1 and a negative 8. So x minus 8 and x plus 1. Factoring with two variables. So far, all the problems that we've had have had just one variable in them. Now we have two. We do the same process. We still have x times x is x squared. But back here, for the last term, we have y times y is y squared. So these are going to be y's in the back. And then we have to figure out what number goes in front of that y. So let's look at 6. This is positive, so we're going to add factors of 6. So 6 and 1 are 2 and 3. And we're going to add them, and we're going to get 5. So which ones add together to get 5? These 2 and 3 do. So 2 and 3. And since this is positive in the middle, we know that both of these have to be positive. So x plus 3y and x plus 2y are our factors. Same thing with this next one. Again, x times x is x squared. Y times y is y squared. And then we have the negative 3. And since we know this is a negative, we know that we're going to have to subtract factors of 3. Factors of 3 are only 3 and 1. And we're going to have to subtract them and get a positive 2. So if we do that, this is going to have to be a positive 3 and a negative 1 will give us a positive 2. So x plus 3y and x minus 1y. And you may see this written this way, x plus 3y and x minus y. They sometimes drop that negative 1 in front of the y. You don't really need it. That's the understood 1. Example 4 is rearranging before factoring. You cannot factor unless things are in the proper order. And proper order is descending order according to the variables. So we need to have anything that has a bigger power all the way to the left. So x squared is the biggest power here, so we're going to write this as x squared. And then here's the one with the first power, negative 4x. And then really this has x to the 0 power, and so it has a 0 power, so it's just minus 21. Now it's in the proper order and we can factor it. And so x times x is x squared. Factors of 21 that when you subtract them will give you a negative 4. So factors of 21 are 21 and 1 and 3 and 7. When you subtract those factors, which one will give you a 4? Well, 3 and 7 subtracted gives you 4, so we know it's 3 and 7. And which one has to be negative in order to end up with a negative 4? Well, the bigger one has to be negative, so it has to be a negative 7 and a positive 3. Because negative 7x plus 3x gives us negative 4x in the middle. So our terms are x plus 3 and x minus 7. Last one, evaluating. This is simply substitution. So when we put this in, we can substitute it. Now, we could substitute it into this equation, or we could substitute it into the factored equation. So what's the factored equation here? Again, factoring, this is x times x is x squared. Factors of 14 are 14 and 1, 2 and 7. And so which ones of those are going to subtract to give us 5? Well, it has to be 2 and 7 subtract. So 7 and 2 are 2 and 7. And that's a positive 5x, so which one of them has to be positive? That's the greater one has to be positive. So it's going to be a positive 7 and a negative 2 will give us the 5x in the middle. And so if we substitute 3 in, if we substitute into the original equation, 3 squared plus 5x minus 14. Oh, we need to put the 3 in for the other x here. So 3 squared is 9 plus 15 minus 14. And that's 9 plus, I'm going to do this first, 1, which is 10. We could also substitute it into this equation here that we've already factored. If we put 3 plus 7 times 3 minus 2, 3 plus 7 is 10, and 3 minus 2 is 1, and 10 times 1 is still 10. We get the same answer whether we put it in the factored form or whether we put it into the equation before it's factored. And the reason they bring this up is just so that you recognize that, and because we are going to be going and solving equations eventually with this. Right now we're just factoring them, but eventually we'll put the equal sign with them and solve them.